Hello guys, welcome on Tesla Adventures. In this video, we are going to start the gravitational potential, and this is a topic which is linked with the electrostatics. So in most of the coaching institutes, we usually teach the gravitation just after the electrostatics, so that by the analogy student can easily solve the gravitation problems. But obviously I'm making this playlist of gravitation, and this has no link with any of other chapter, so you can a student which is of class 11th also easily understand the gravitation by this playlist, and there is no need of reading the electrostatics for this. So obviously this is an independent playlist of gravitation. So in this topic, gravitational potential, it is defined as the work done by external force in slowly bringing a unit mass from infinity to a point in gravitational field. Let us examine this definition. So let us now imagine that there is a mass m, and this mass m is making the gravitational field around it, and there is a point P which is at a distance of r from this mass m, and we have to find out the gravitational potential at this point P due to this mass m. So for this, let us apply the definition that the gravitational potential is the work done in bringing a unit mass from infinity to this point slowly by the external force. So obviously we know that if we will release this unit mass at some point, then this mass would attract this unit mass, and it would attract this mass to point P, and this mass would accelerate till this point P, and even it would accelerate till it reaches this point m. So we have to bring this mass slowly. Slowly is a technical word which means that the acceleration of this mass should be zero, and its velocity should be negligibly small. So for this to happen, we have to apply some force, external force, in such a way such that the net force acting on this mass becomes zero, and therefore we have to apply the force in opposite direction of the gravitational force, and the magnitude of our force should be equal to the gravitational force magnitude at all the times. So obviously gravitational force is a variable force, therefore our force is also a variable force. Now let us see that the work done by our force F external would be equal to dW would be equal to F external into dx, and there is a negative sign. This negative sign is due to the fact that dx is in opposite direction and F external is in opposite direction. Okay, so there is a negative sign. Now if we substitute the value of F external, which we know that F external is equal to the gravitational force, so at this instant of time when this mass is at a distance of x from this capital M, then the gravitational force acting on this mass would be G m into 1, because its value is 1 upon x square into dx. And now we have to integrate this expression. So dW integration would be equal to W, and there would be a integration of minus gm by x square into dx. The limit of x would be from infinity to r, because initially this mass was at infinity and finally it is at this point r. Okay, now we have to apply another negative sign. It is due to the fact, you can see that the coordinate system to measure the x is this one, and dx is in the opposite direction of x. Obviously we know that dx is the small element of x, and therefore dx would be positive in the direction of x. But you can say that you can see that dx is positive in this direction while x is measured in this direction. So due to this inverse coordinate system, we have to apply a negative sign. So we will put a negative sign, and there would be a positive sign here. So this work done would be equal to gm by gm integration dx upon x square, and the limit would be from infinity to r, and the integration of 1 upon x square is minus 1 upon x, and limit would be from infinity to r. So work done is equal to minus of gm by r, and this is plus of gm by infinity. So 1 upon infinity is 0. So work done in bringing this point mass slowly from infinity to that point is gm by r, and this work done is defined as the gravitational potential. So the gravitational potential is equal to minus of gm by r, and the symbol of this gravitational potential is V. Now this negative sign indicates the fact that the work done by external force is negative. Obviously this indicates, this negative sign indicates that the work done by F external is negative. Obviously you can see that the displacement of this mass is in this direction, and the external force is acting in this direction. So the work done by this external force is negative, and therefore the gravitational potential is negative. Now you can see again that why we are mentioning that it is the work done in bringing a mass, unit mass from infinity. It is due to the fact that infinity is the reference point to measure the gravitational potential, because the potential of infinity is 0, and we always refer the reference point to that point where the quantity becomes 0. So V at infinity will be 0, which means that the infinity is the reference point for measuring the gravitational potential. So in the definition we always refer that gravitational potential is the work done in bringing a unit mass slowly from infinity to the point in gravitational field. Now this gravitational potential is always negative, and this is due to the fact that gravitational force is attractive in nature. We have already discussed this point. And the second point is the fact that gravitational potential is always defined for a point in the gravitational field and not for a system. You can see that we have defined the potential gm by r minus gm by r as the potential at the point P, that point P. Okay, this one. So gravitational potential is something which is defined for a point, and it is not defined for a system. It would have no meaning to say that the gravitational potential of this system is minus gm by r. So obviously gravitational potential is not defined for a system, and potential energy is defined for a system, while this gravitational potential energy is defined for a system of masses. Now gravitational potential is a scalar quantity, which we all know that it is the work done, and therefore it is a scalar quantity. The gravitational potential of infinity is 0, therefore infinity is taken as the reference point to measure the gravitational potential. We have already discussed this point. Now the gravitational potential can also be defined as the potential difference between that point and infinity. Obviously some people say that gravitational potential is an absolute quantity. So this is a little bit wrong to say, because when we are referring the potential of this point P, then we are also using the reference of infinity. So which means that we are referring that the potential of this point P is minus gm by r with respect to infinity, because the potential of infinity is 0. Okay, so we can also say that the potential of any point is also the potential difference between that point and infinity. Okay, now the gravitational potential can also, now this unit of the gravitational potential is joule per kg. We all know work done per unit mass. Now let us discuss the gravitational potential difference. You can see that it is defined as the work done by external force in slowly displacing a unit mass from one point to another point in the gravitational field, which means that it is simply the difference of gravitational potential of 2 points, which means that if we have to displace a unit mass from point B to A, then what will be the work done by our external force in displacing the unit mass from B to A is called as the potential difference between A and B. So we know that the potential of A is equal to minus gm by Ra, while the potential of B is equal to minus gm by Rb. So the potential difference of A and B is Va minus Vb is equal to minus gm by Ra and plus gm by Rb. So this is gm and 1 upon Rb minus 1 upon Ra. Okay, so this is the potential difference between any 2 points. It is also very important to note that the gravitational potential is a negative quantity, and as we will move in the direction of gravitational field, the gravitational potential will decrease, because you can see that at this point P, or we can take the example of that figure, you can see that the gravitational field at both of these points is in the backward direction. Okay, so and the potential of A is greater than potential of B. You can see, in fact, the potential of A is less than the potential of B. You can see that VA is more negative than VB. So VA minus VB we have calculated, and it is negative quantity because 1 upon RB is less than 1 upon RA. So this would be a negative quantity. So we know that VA minus VB is negative, and therefore we can say that the potential of point A is lower than the potential of point B, which means that when we are moving from B to A in the direction of gravitational field, the potential decreases. Likewise, in the case of electric field, which we have already discussed in electrostatics, that when we move in the direction of electric field, the electric potential also decreases. Okay, so this is the potential, and in the next video we'll be bringing the gravitational potential energy. Thank you. Hello guys, welcome on Tesla Adventures. In this video we are going to discuss the gravitational potential energy. We have already discussed the gravitational potential, and it was the work done in bringing a unit mass from infinity to a point in gravitational field. But in this case there is a slight difference, that the gravitational potential energy is the work done in bringing a given mass. Instead of unit mass, the work done in bringing a given mass from infinity to a point in gravitational field slowly by the external force. So we already know that the work done is equal to, in fact the potential, gravitational potential is equal to the work done in bringing a unit mass. So the gravitational potential at P is equal to minus gm by r, and this is the work done in bringing a unit mass. So obviously the work done in bringing a m mass, given mass, would be m times of v, because in bringing a 1 kg mass we have done a work done of v. So in bringing a m kg mass, the work done would be m into v. So this work done will be called as potential energy of the system, Now what system to which we are referring? You can imagine that this mass m, when it would arrive at point P, then it would create a system with capital M, and there would be a system of two masses which are at a distance of r from each other. So this potential energy would be minus gmm by r. This is the potential energy of the system. So potential energy is always defined for a system, obviously, because it is a quantity which is held by a system, not a single body or not an individual body. And the gravitational potential energy, you can also define that the work done in arranging or assembling these masses m and m from infinity to these points is called as the gravitational potential energy of the system. Okay, so the gravitational potential energy is also defined as the work done by external force in slowly assembling the constituent masses of a system from infinity, obviously. The gravitational potential energy is only defined for a system of masses and not for a point, which we have already discussed. The gravitational potential energy is always negative, and the fact that the gravitational potential energy is always negative is due to that the force of gravitation is always attractive. So the gravitational potential energy will always be negative. Okay, so if in some question it is being asked that the assertion is the fact that the gravitational potential energy is always negative, and the reason is the fact that gravitational force is always attractive in nature, so the assertion will be correct and reason will be correct, and reason would be the correct explanation for the assertion. Okay, now the gravitational potential energy is a scalar quantity. Obviously energy is a scalar quantity, and the gravitational potential energy is of two types. The first energy is the gravitational interaction energy, in which there are two masses, like we have derived the formula minus gmm by r. So this is the interaction energy, and there is a second type of energy which we would discuss in the later part, and this is called as gravitational self energy. This we would discuss in the later part. So this is the potential energy, gravitational potential energy. And in the next video, I would be bringing some concept illustration problems to illustrate the complete analytical applications of gravitational potential and gravitational potential energy. Thank you.